What's up, brothers and sisters? I am your host, your brother, your professor, Mr. O'Neill Barnaby, founder and director of the Black Math Academy, here with another video showing you what intelligent black society is all about. Right, welcome to our fourth and final part of our four-part series talking about how to solve quadratic equations. In this video, I'm going to talk about the fourth step, which is the quadratic formula itself. So I'm going to give you guys an example to show you how the quadratic formula actually works. All right, so let me show you how it's done. All right, so remember the four steps real quick. We've got pull out the GCF, the AC method, complete the square, and the quadratic formula. The quadratic formula is what we're going to be talking about today. You definitely want to use this option when the first three fail. For some reason you can't do it or it's not efficient. The quadratic formula is your option of last resort. As an aside, you actually can use the quadratic formula to solve any quadratic equation. It actually will work. It just tends to be tedious. So that's why we have four options, because you want to use the most efficient option to solve the problem, not just any option. But with that said, we've mentioned it before and we'll mention it again. You definitely want to make sure your quadratic equation is in standard form. Standard form, if you will remember, is ax squared plus bx plus c equaling 0. So you want to make sure it's in that form first before you do any sort of solving. But for this particular example, we're going to need the quadratic formula itself to be able to solve it. So let me show you what the quadratic formula looks like. All right, so let me separate it here. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I don't even want to hear it. If you guys can remember the Savage dance moves, if you guys can remember the lyrics to all those songs that you listen to, if you guys can remember the directions to your grandmother's house, then you can remember this formula. Stop the whining, stop the complaining. So this is the quadratic formula itself, and we're going to be using that to solve quadratic equations. So one thing you'll notice is that within the standard form, let me use this marker. You've got the a term, the b term, and the c term. And in the equation, you've got those values as well, b, a, c, and a. So that's where the values come from. So when you have the equation itself, you just throw those values, a, b, and c, in the quadratic formula itself where they belong, and then just simplify. Let me give you an example. Let's say you had the equation 25x squared equals 30x plus 11. All right, so that's our example. All right, so we already have a problem. It's not written in standard form. All right, so this equation here does not look like the one right above it, ax squared plus bx plus c equaling 0. Our equation is not set equal to 0, so we have to do that. So we can either move the 25x squared to this side, and the left side will be equal to 0, or we can move the 30x and the 11 to the left side, and the right side would be set equal to 0. It's up to you which way you want to move it. It actually doesn't matter. All right, so to keep things simple as I can, I'll move the 25x squared to this side. So it would say, so subtract 25x squared to both sides. What you get is negative 25x squared plus 30x plus 11 equals 0, even though it should be on the other side. But regardless, here's our equation. Negative 25x squared plus 30x plus 11 equals 0. So now that's written in the right form, we can then extract the values that we're looking for. So keep in mind, we want the a, b, and the c term to go in the equation itself. So to make things a bit clearer, the value of A would be this negative 25 because it matches with the coefficient of the x squared term. So A is equal to negative 25. B would be equal to 30. It's a positive number, so B would just be 30. And C would be equal to 11 because C is the last number in the equation. So C is 11. And these are our three numbers that we're going to be using to plug into the quadratic formula and then solve. So let's do that. So following, let me actually box in the equation so you know which ones we're talking about. Here's the quadratic formula up here in red. So we're going to be using that. So plugging in the values A, B, and C where they belong, here's what you get. X equals, B is, it says negative B, our B is 30, so that would say negative 30. Plus or minus the square root of B squared. B is 30, so the quantity 30 squared minus 4. That times A and C. A is negative 25. And C is 11. And this value is all over 2A. Oh, sorry, we know what A is. Excuse me. A is 25. I'm sorry. Negative 25. So here's what we have. Negative 30 plus or minus 30 squared minus 4 times negative 25 times 11 divided by 2 times negative 25. Okay. So we then just simplify the formula itself. So I would start with everything I could inside the radical and also the denominator. All right, so doing that, we get x is equal to negative 30 plus or minus 30 squared. Let me write the square root first. 30 squared is 900 because 30 times 30 is 900. Negative 4 times negative 25, that's 100. 100 times 11 is 1100. So 1100 is a positive number, so we're going to be adding it inside the radical. So plus 1100 all over 2 times negative 25, which is negative 50. All right. Then we can simplify the radical on the inside by adding. So x would be equal to negative 30 plus or minus the square root of 900 plus 1100, which happens to be 2000 all over 50. Sorry, negative 50. And then here we have to actually simplify the radical itself. I need more room, so let me erase this. All right. So we have to square root this 2000. That's the first thing we should do. Unfortunately, it's not a perfect square, so we can't just simplify it, very easily. So what we can do is separate the number 2000 into two factors where one of them is a perfect square and the other one is not a perfect square. So basically we want factors of 2000, but specifically one's got to be a perfect square. All right, so the way to do that, I'll point this up there. So this would be x equals negative 30 plus or minus the square root of 400 times 5 all over negative 50. All right. So we have this radical now, 400 times 5 inside the radical itself. And once you have that, we can actually take the square root of it now, but we can do them individually because it's a product. So the square root of 400 and the square root of 5 we can do. But the 400 is the only one we really actually can do because that's a perfect square. The 5 is not a perfect square because it's prime. So that means we're going to leave that value alone in the end. Let me show you. So the square root of 400 plus or minus is actually 20 because 20 times 20 is 400. So that's what makes it a perfect square. So because it's a perfect square and you solve it, it comes outside the radical when you simplify it. So 20 comes on the outside. And the square root of 5, because we actually can't solve it or simplify it, you just leave it alone. So it goes right next to the 20, the square root of 5. And this is all over negative 50 once again. So this says the negative 30 plus or minus 20 times the square root of 5 divided by negative 50. And that's how you simplify a radical that's not a perfect square. I'll do that in another video some other day. Anyway, here we can now simplify the fraction. It is negative 30 over negative 50 plus or minus the 20 root 5 over negative 50. So we can solve them both individually the way it's set up. So negative 30 over negative 50, if you were to simplify that fraction, that becomes 3 over 5 plus or minus. And then 20 times root 5 over negative 50, you can only simplify similar parts. That would be the 20 and the negative 50. So when you simplify that, you get negative 2/5 over root 5. I'll just put them both over. So negative 2 over root 5 over 5. Negative 2 root 5 over 5, excuse me. So it becomes this. So because we have two values, 3 over 5 and negative 2 root 5 over 5, both of those fractions are under the same number. They have the same denominator of 5. So we can put them both under the same fraction as opposed to two separate fractions. So x would then equal 3 plus or minus negative 2 root 5 all over 5. And this is going to end up being the answer to the question. It'll be x equals this value here. 3 plus or minus negative 2 root 5 over 5. So if you don't know, this is actually two solutions. It does say one of them is 3 plus negative 2 root 5 over 5. The other solution is 3 minus negative 2 root 5 over 5. And those would be the two solutions to this equation. And there you have it, folks. Once again, the Black Math Academy continues to demonstrate why we are clear, concise, and articulate, which makes us without peer. And we happen to be your premier source for mathematics tutoring. Don't forget to like, share, comment, subscribe, and follow all of our social media pages, our Facebook, our Instagram, and our YouTube. And always remember that power concedes nothing without demand. It never did, and it never will. Be easy, y'all.